Question 5a, we have to show that the equation 4 sin x plus 5 upon 10x plus 2 upon sin x equals to 0 may be expressed in the form a cos square plus b cos x plus c, where a, b, and c are integers. So in the first step, the equation is 4 sine plus 5 upon tan. Now we know that tan x is equals to sin x upon cos x. So when we substitute sin x upon cos x, this can be written as 5 cos x upon tan x, cos x upon sin x, plus 2 upon sin x is equals to 0. Taking the LCM, so this is a sin x over here, and this is also sin x. Now taking the LCM, so the LCM will become sin x. There's a 1 over here, so this will multiply by sine. So this will become 4 sine squared plus 5 cos plus 2 is equals to 0. So sine will multiply by 0, and the equation will be 4 sine squared plus 5 cos plus 2 equals to 0. We know that the identity is sine squared plus cos squared equals to 1. So sine squared can be written as 1 minus cos squared. So substituting 1 minus cos squared in place of sine squared, this will become 4 into 1 minus cos squared plus 5 cos plus 2 equals to 0. Expanding this, we'll get 4 minus 4 cos squared plus 5 cos plus 2 equals to 0. So this will become minus 4 cos squared plus 5 cos, and this will become 4 plus 2 plus 6 equals to 0. Now, as we have to bring the cos squared term in positive, so we can change the sign and write it as 4 cos squared minus 5 cos minus 6 equals to 0. In part B, it says, hence solve the equation 4 sine plus 5 upon tan plus 2 upon sine equals to 0 for 0 to 360. So in the first step, we already have converted this to cos form, which is 4 cos squared minus 5 cos minus 6 equals to 0. Applying middle term breaking, so we'll get, we have to get minus 24 and minus 5. So we'll use minus 8 cos plus 3 cos minus 6 equals to 0. Taking 4 cos common, we'll get cos minus 2. And taking 3 common, we'll get cos minus 2 equals to 0. Simplifying, we'll get cos minus 2 and 4 cos plus 3 equals to 0. So finally, the equation will be cos theta will be is equals to 2 and cos theta will be is equals to minus 3 upon 4. Now, as cos cannot be greater than 1 or less than minus 1, so we'll reject cos theta is equals to 2 as it will give no solutions. Now for this, first we'll find the basic angle. So the basic angle will be cos inverse of 3 upon 4. Substituting this in the calculator, so we'll get 41.409 as the basic angle. So this will become 41.409 degrees. Now as cos is negative over here, so first we can make the 4 quadrants. We know that cos is positive in the first and the fourth quadrant, but as there's a negative sign, so we'll make this basic angle in the second quadrant. This angle is 41.409, and in the third quadrant, this angle, the basic angle, which is always made with the x-axis, is 41.409. To find x, we'll measure the angle anti-clockwise from the x direction. So the first answer will be 180 minus 41.409. So this will become 180 minus 41.409. And the second angle will be 180 plus 41.409. Writing our answer to 3 significant 1 decimal place in case of degrees. So this will become 138.6 degrees, and this will become 221.4 degrees. So the values of theta, we'll have two values, 138.6 and 221.4 degrees.